All right, so today we're going to talk about properties of logarithms. So one thing we're going to talk about is what we call the change of base formula, and this is going to allow us to use our calculator. So for example, we're going to do a problem like if you look at example 1 down here, if you look at example 1, you'll notice that we have a base of 5 and we need to get to 31. So 5 times what is going to get us to 31, and this isn't easy. So we can use the change of base formula to allow us to calculate this in the calculator, because the majority of calculators do not allow you to put in a base of 5. Okay, so if we look up here at the general formula, what we're going to do is we're going to take the log of x and it's going to get divided by the log of a. So that is the change of base formula. And since this is a log of x over log of a, this also applies if we have ln of x and an ln of a. So again, remember ln is really log base e. So if we have both of those, this property also applies to natural logarithms. Okay, so what that allows us to do over here is, so what we're going to do is go log 31 over log 5. Now, in this case, you can leave it like this. For using your calculator, you're going to get an approximate value of 2.1337. Okay, and typically 4 decimal places is used for rounding using these types of numbers. So if we look at example B, change of base is going to tell us to go log 25 over log base 4. And if you were to type this in the calculator, you get approximately 2.320 is going to be your answer. Okay, so that's a very important property called change of base formula. And again, you would use your fraction feature of your calculator and plug that in. And if you notice in both of these, the bases are base 10. So it would work in any calculator that you guys have with the log button. Okay, next we have the product property. Okay, now this is going to be a little bit like the exponent properties. So if we have a log and then 2 terms getting multiplied, what we're going to do is we're going to split them up. So we end up getting a log of x, and then it's going to add to the log of y. Okay, so that's kind of like the old exponent property. If you multiply 2 bases, you add the exponents. So in this case, we can split the product up, and then we can add them. And then vice versa, if you have the same base, and you're adding 2, then you can condense them into x times y, which we'll see in a little bit. Okay, the next is the quotient property. So just like we did in exponents, the quotient property, we're going to subtract. So we have log of x minus log of y. Okay, and it doesn't matter what the base is, the base would stay with your logarithm. So in this case, because it's not there, it's 10. And then we just subtract log of x minus log of y. All right, now the power property is a little bit different. So what we're going to do on the power property is this number, so this answer here, this x, if it has a raised power, we're going to move it out front. So in this case, we're going to have n times log of x. So anytime this term here is raised to a power, that number goes out front. In this case, it would be n. Okay, so let's take an example here and see how we do here. So we want to use use the power property of powers, all right, to show how this would work. So what we have is this here. We have log of 25 over the log of 5. Okay, and if you were to type that in, you're going to get exactly 2. And that is the same thing if we evaluated it like we learned before. So what is 5x equals to 25? And we know that x has to equal to 2. So this is 2 different ways to show that the change of base formula works, and also our old evaluation method works. Okay, so if we look at example 3, what do you notice is that we have an exponent on the 16. So our property is going to tell us to move that in front. So it's going to be 3 times log base 2 of 16. Okay, and what is log base 2 of 16? This is going to give us 4, and then times 3, which gives us a final answer of 12. Okay, so the 3 just goes along from the exponent. Log base 2 of 16 is 4, and then 3 times 4 is 12. Okay, the next one here, we have log 5 plus log 2. So this plus means we're going to combine them. And also notice what the base is. The bases are 10. So our property tells us that we can do 5 times 2. And we know that 5 times 2 is 10. And then what is our base here? The hidden base is also 10. So log base 10 of 10 is 10 to the x equals 10. So x has to equal to 1. So our final answer is 1 here. Okay, so again, the first property, we condensed it to the product property, and then we just evaluated it. 10 to the x power has to equal to 10, and that number is 1. Okay, all right, next, we see a number out front of an ln and e, and we have some exponents here. Okay, so what we want to do in this case is, what is ln of e to the 4th? Okay, so anytime we have ln to an e, those cancel each other out, and then whatever's left over is our final remainder here. So when we cancel these out, we're left with just a 4 and then times 5. Okay, over here, ln and e cancel out, and so we have 3, and then we have to subtract. So we end up with 20 minus 3, which is 17. Okay. All right, in the next one, this would help if we rewrote e as a rational exponent here. So we have ln of e. Okay, now if we have the 5th root, that's going to go in the denominator of our exponent. Okay, and then what do we say when we have ln and e? They cancel each other out, and so we're just left with 3 over 5. Okay. All right, on the next one, we have base 3, which is really nice with the subtraction. So we're going to use our quotient rule, which tells us that we could do log base 3, 45 over 5. And in this case, we can simplify that 45 and 5 to get 9. Okay, and so what power is going to equal to 9? And that is going to give us 2. So our final answer in this case is going to be 2. All right, one more example here. We have a negative parenthesis, so we have to be careful because a negative parenthesis means this is undefined. Okay, because in general, our domain is x is greater than 0, and in this case, x is less than 0. So this is a undefined domain. Okay. All right. So now what we're going to do is we're going to work on expanding these expressions by using our properties. So if we look here in example 4a, we have a 25, an x cubed, and a y, and they're all being multiplied together. So what we want to do in this case is we're going to end up having 3 things that get added together. So we're going to split this up. So we're going to end up with a log base 5 of 25. Okay. Then we're going to have this x cubed is going to go in front of the next term. So it's 3 times the log base 5 of x. Okay. And then we're going to add log base 5 of y. Okay, so that's what we end up having. So log base 5 of 25 is going to give us 2 plus, now in this case, because we have xy, it doesn't really do anything for us. So plus 3 times log base 5 of x plus log base 5 of y. And that, unfortunately, is your long answer because we expanded it, not condensed it. So sometimes we need it in one form because it helps us, and sometimes the other form helps us. So that's where we're at in that problem. So let's take a look at this next one. We have ln, which is no different than a logarithm, and we have a quotient here. So what's going to happen in our quotient is anything in the bottom is going to get subtracted. Okay, so this is a little different maybe than order of operations that you're used to. So we know we're going to do an ln of 10. Okay, and now we're going to subtract an ln of w. And then we're also going to subtract the ln of the y. Now, because we have an exponent on top, it goes in front. And then we have ln of y. And that is our final expanded form of that particular expression. Okay. All right, let's take a look at this one here. So if we look at this may look confusing, but we'll break it down step by step. So what we have on top is log of base 10 and then b squared. We're going to expand this on the next step. So I didn't move the 2 down. I'll do that in the next step because I want to show you what we're going to do on this next part. So because it's a square root, I'm going to put c to the 5th and d in parentheses because that is what is getting square rooted. So what is the exponent for a square root? It's 1/2. Okay. So now in this part, we have 2 terms getting multiplied together, but because they were in the bottom, we're actually going to subtract them. So that's where we have to be careful here. This is a unique situation, which we'll see in a second. Okay, so we're going to take the 2 and we're going to bring it down in front of the log. Okay, and that is going to be good the way it is. Now, this mess here, we have to bring the 1/2 down, and because it's going to both c and d, we're going to have this weird thing here. So it's really log c to the 5th times 1/2 because we're using the exponent rules, and then we're going to minus a log of d to the 1/2. Okay, again, from the exponent rules. So we could have skipped a bunch of steps, but I'm trying to go slow and expand this out. So the first part here, again, is good. We don't have to touch that. Now, we have this exponent here of 5/2. So that's what's going to go in front of the logarithm. Now, you could write 2.5 if you want, or 5/2. Either one would be fine. And then we have c by itself. Now, we have an exponent of 1/2. So that is going to go in front of that log. Okay, again, why do we have 2 subtractions here? Because both of these came in the denominator, so they have to get subtracted. The numbers in front are a result of their exponents that they had in the original form. Okay, so again, this is expanding. Now, let's take a look at a couple condensing. Okay, a couple condensing here. So one thing we can look at is this is an a value, and so is this. And so if we had something like this, like a, let's try this, like 2a plus 4a. Okay, what can we take out of this thing? We can take out a 2. So that's exactly what we're going to do in these logarithms here. So we're going to take out a 2, and then what's left over is log 9 plus 2 log x minus 6. Okay, so this allows us to do some interesting things. So this 2 now is just going to go along for the ride. Okay, there's nothing we're going to do. So now if we have a log of 9 and we're adding a log of 2 times the log of x minus 6. So before we do the adding part, what we want to do is bring that 2 up here. So we're going to end up with the 2 and then log of 9 plus log of x minus 6 squared. Okay, so all we did was that power property, which takes the exponent to the front. Okay, so now what we can do is multiply the inside here. So we have 2, and then in parentheses, the log of 9 times x minus 6 squared. Okay, so because we're adding, that adding is allowing us to get that step there. Okay, so now what we're going to do is we're going to expand the x minus 6, multiply it by 9, and you'll see the final answer. So this 2 comes down here. Again, we don't touch it. And then we have our logarithm of 9, and then in parentheses is going to be this expanded, which is x squared minus 12x plus 36. And then this is the number we distribute, not the 2. This number here gets distributed. So we have 2 log 9x squared minus 108 x, okay, plus 324. So that would be your final answer. It's a big mess. So there is a lot of work in this problem. So if you need to go back and review this, by all means do so. Okay. All right. The next one here is we have an adding and then we have a subtracting. So we know that one of these things is going on top and then we have some stuff going on the bottom. So because we have a number on top on all of these, we know that we can move all of those things up. So we have a log of x cubed plus 4 times a log of, what's a day without me screwing up? Log y to the 4th, okay, minus log z to the 5th. Okay. All right. So we can combine these into the top, and then this is going to go in the denominator. Okay. So we have log of x cubed y to the 4th over z to the 5th. Okay. Because we're adding these two, they get put up on top, and then this one's subtracted, so it goes on the bottom. All right. Okay, the last example here before you guys do some practice. So if we have a 4, we know that we're going to get ln of x to the 4th. Okay, and then we're subtracting an ln of an x plus 3, and then subtracting again an ln of an x minus 3. So since these two terms are being subtracted, they both are going to go into the denominator like this. Okay. And then the x to the 4th goes on top. And then all of this is the parenthesis of ln. And if we wanted to take it a step further, we could on the denominator. This might be okay the way it is. Sometimes if we're substituting values in, this form is going to be better because it makes it kind of easier to get our values with the x plus 3 and x minus 3. Sometimes it might be written in this kind of form here, which is going to be x squared minus 9. This form isn't that hard to figure out, but sometimes the factored form would work. So either of these answers would be correct. Okay, so there's a lot here. There's lots of properties to mess with. This is going to take a lot of practice to do. So give it a try and see how you guys do.